Lesson 2. Network models. Now we will see some examples as well as models related to network. They will help you to understand what's going on. Okay, let's think that you are sending a letter. By the way, I mean regular paper-based letter. So by the way, to me, writing paper-based letter to your friend is much more better, much more interesting either than sitting in front of computer. So think about it. Okay, just returning to your letter. So what do you think? How the post office route the letter to its right destination? I mean, when you are sending a letter to your friend, how the post office delivers it to him, but not, for example, to me. Okay? In many ways, computer networks work like a post office. Let's look at this in more details. Okay, consider that I want to send a letter to my friend who is living in United States and his name is Armen. I will write his name and address from the most specific to the most general. Also, I will write my name and address and will take it to the post office. The same concept can be implemented for email. Just we are writing the email text, adding subject, and writing friend's email address and pressing send button. It means that our email already in post office. Let's go back to my paper letter. My country is Armenia and where my friend lives is United States. They are located far from each other. It means my letter will travel from one country to country, and after all it will reach to the United States, then to the right state, then right city, right street, and to my friend's house, where his parents will give him his letter and he will read his letter from me. The key moment is that we don't need to change address on the letter during its trip from one country to another. The computer networks work at the same way. When we need send an email or any information, data, we will not change its source or destination address, wherever it is, until it gets to the final destination point. To understand networking, it helps to start thinking in layers. This model was developed starting from 1977 by International Organization for Standardization, or simply OSI. The model was created to break up the process of sending data from one computer to another into 7 steps or layers, called the model OSI, or Open Systems Interconnection model. This model identifies the steps and functions that must be completed at each layer when one computer communicates with another one. The OSI model provides only guidelines on how computers communicate over a network. It does not provide detailed procedures on how to actually make this communication happen. These 7 layers like 7 blocks which stands on each other. This combination of layers we call network stack. It is another key moment of our course. This model is very important key moment. So I think that need to help you to understand why we break the data transfer process into steps. That's why I will bring example. Did you see the animation movie Flintstones? Yes, I think. So let's assume that Fred needs to go to the lake. Fred is the raw data in our case, just the data, clean data, nothing more. We need to put on his clothes to be sure that he will not get a cold. Attached to him support his friends. You know him. We call network words, it's a header. And we are doing this to be sure that he will not be eaten by dinosaurs, and give them a car to reach the lake quickly. Yeah, in this case we are encapsulating in words of networking. And they will go.
Okay, now let's continue. We learned that OSI model consists of 7 layers: physical, data link, network, transport, session, presentation, and application. Again and again, OSI reference model provides guidelines on how two computers communicate over a network. It does not define specific procedures on how should two devices communicate. By the way, these procedures in networking languages call protocols. Protocol is a formal set of written rules or procedures that computers must understand, accept, and use to be able to talk to each other over a network. Different protocols are used at different layers of the reference model OSI. Two computers must use same protocol at the same layer for the data to be communicated correctly. Protocols like languages. Let's continue and have an example. Protocols like a language. To make two people communicate each other, then first thing, they need to speak the same language. Two people. How they communicate? Two people. One is asking a question, another is answering to it. The same way protocol communication is doing. Protocol also. More than just a common language, protocols are like rules of ethic frequently encountered among spoken languages. So the first thing, two people must communicate in only that case that if they speak the same language. So exact the same concept can be applied to network protocols. It means each computer should know when to send the packet, what packet he should send, or what to do if the packet was not sent, what to do if two packets simultaneously at the same time he received, and so on. In the same way OSI model works. When sending an information, any data to receiving computer, each layer communicates to the same layer at the remote side, at the receiving computer. Only in this case the communication can happen. So physical layer can communicate only with a physical layer in a receiving side. Data link layer on receiving or sending computer will communicate only with data link layer in receiving computer side, and so on. Okay, now let's see how data flows through the network when host A sending an information, data to host B. When host A, it could be computer or other network element, want to send the data is going through all the layers from upper one to down one, where in opposite side near the host B the information converts from the physical layer up to application layer. So let's see how does it happen. We have a data and we want to send it to host B, to computer B. In this case, application layer, adding to a data its header, you can see as the same color as the application layer, and sends to the presentation layer and send it down. With its layer, with the application layer header, data received to presentation layer. Presentation layer consider the data with the application layer header as a data, as a new data, and adds to it his layer. After it, presentation layer sends to session layer. Session layer considers all this information including data, application layer header, and presentation layer header as a one little bit bigger data packet and adds its own header, yellow one, sending it to the next down transportation layer. Transportation layer, of course, doesn't know anything about application layer header, presentation layer header, session layer header, and even the data, even the raw data. So it's considered as the big data packet, information packet, adding to it its own layer and sending to the next layer, which he communicate with. Network layer, of course, like the other ones, adding to the huge packet its layer, its header, and sending to data link layer. Data link layer finally completes the packet, adding to them its header and sending to physical layer, where adding some electrical or optical some information, some header, it's sending to another computer through medium. So medium is a network, is a tube, could be fiber optic cable, could be wireless link, could be copper cable or other thing. Of course, host B received it, but with the data received, but with all the headers. Now the data should go up, removing all the headers step by step, because the upper layers cannot process the packet until they see their own header. So that's why physical layer doing some checkups and removing its header, sending it to data link layer. Data link layer, of course, looking over all the data. Data link layer also doesn't know about any data, any information, any other headers, and can see only its header. While doing some testing, some checkups, it's removing its header and sending to network layer. Network layer, of course, removing its header and sending it to transport layer. As you can see, the data, overall the data, all the information coming smaller, smaller and smaller, and in the final step we will get only the data, raw data, without the headers, without anything. So, and we get to the presentation layer, where he is doing encryption, decompression of the packet and sending to application layer, where the layer removes its data and process the data. And now host B receives the data packet. As you can see, this process is a difficult process, and each packet you send through network, even you are sending hi to your friend through Skype, through other chat, each packet processing in this way. This is the concept. This is the main concept of the networking OSI model. This process, when a host A adding each application in host A adding its own header, and from application layer down to physical layer, we call encapsulation. Again, encapsulation. And another process where host B processing data, removing the headers from physical layer up to application layer, we call de-encapsulation. De-encapsulation. So, at host A, at ascending end, we are encapsulating the packet, and the receiving side is de-encapsulating the packet to get the data. Okay,